Okay, good afternoon, everyone, and myself Hari Krishnan, and my topic is surface flow irrigation tanks. First, let us see about the introduction to this topic. Um Surface irrigation is the oldest and widely used method of water application to agricultural land. The term irrigation refers to a broad class of irrigation methods in which water is distributed over the field by overland flow. A flow is introduced at upper edge of the field, which covers the field gradually. The water from front advance is dependent largely on the differences between the inflow onto the field and the accumulating infiltration into the soil. In addition, other factors such as field slope, surface roughness, and the geometry or shape of the flow cross section also influence advance rate. In this presentation, let us see in detail about the surface irrigation. And the next one is methods involved in surface irrigation. The classification of surface methods is perhaps somewhat arbitrary in technical literature. This has been compounded by the fact that a single method is often referred to with different names. In this guide, surface methods are classified by the slope, the size, and the shape of the field, the in conditions, and how water flows into and over the field. Each surface system has unique advantages and disadvantages depending on such factors like initial cost, size and shape of the fields, soil characteristics, nature and availability of the water supply, climate, cropping patterns, social preferences and structures, historical experience, and influences external to the surface irrigation systems. Based on this, there are four types of methods in surface irrigation tanks. First one is basin irrigation, border irrigation, furrow irrigation, and uncontrolled flooding. Let us see in detail about one by one. First one is basin irrigation. Basin irrigation is the most common form of surface irrigation, particularly in regions with layouts of small fields. If a field is level in all directions, is encompassed by a dike to prevent runoff, and provides an undirected flow of water onto the field, it is herein called a basin. A basin is typically square in shape but exists in all sorts of regular and irregular configurations. It may be furrowed or corrugated, have raised beds for the benefit of certain crops, but as long as the inflow is undirected and uncontrolled into these field modifications, it remains a basin. Uh, the time There are few crops and soils not amenable to basin irrigation, but it is generally favored by moderate to slow intake soils, deep rooted and closely spaced crops. Crops which are sensitive to flooding and soils which form a hard crust following an irrigation can be basin irrigated by adding furrowing or using raised bed planting. Reclamation of salt affected soils is easily accomplished with basin irrigation, and provision for drainage of surface runoff is unnecessary. Of course, it is always possible to encounter a heavy rainfall or mistake the cutoff time, thereby having too much of water in the basin. Consequently, some means of emergency surface drainage is good design practice. Basins can be served with less command area and field water courses than can border and furrow systems because their level nature allows water applications from anywhere along the basin perimeter. Automation is easily applied. And uh, basin irrigation has a number of limitations, as already mentioned, are associated with soil crustings and crops that cannot accommodate inundation. Precision land leveling is very important to achieving high uniformities and efficiencies. Many basins are so small that precision equipment cannot work effectively. The perimeter dikes need to be well maintained to eliminate breaching and waste, and must be higher for basins than other surface irrigation methods. To reach maximum levels of efficiency, the flow per unit width must be as high as possible without causing erosion of the soil. When an irrigation project has been designed for either small basins or furrows and borders, the capacity of control and outlet structures may not be large enough to improve basins. And the next type of irrigation is furrow irrigation. Furrow irrigation avoids flooding the entire field surface by channeling the flow along the primary direction of the field using furrows, creases, or corrugations. Water infiltrates through the wetted perimeter and spreads vertically and horizontally to refill the soil reservoir. Furrows are often employed in basins and borders to reduce the effects of topographical variation and crusting. The distinctive feature of furrow irrigation is that the flow into each furrow is independently set and controlled as opposed to furrowed borders and basins where the flow is set and controlled on a border or basin by basin basis. And the next thing is furrows provide better on-farm water management flexibility under many surface irrigation conditions. The discharge per unit width of the field is substantially reduced and topographical variations can be more severe. A smaller wetted area reduces evaporation losses. Furrows provide the irrigator more opportunity to manage irrigations towards higher efficiency as field conditions change for each irrigation throughout a season. This is not to say, however, that furrow irrigation enjoys higher application efficiencies than borders and basins. As discussed about there are several disadvantages with furrow irrigation also. This may include an accumulation of salinity between furrows, an increased level of tailwater losses, the difficulty of moving farm equipment across the furrows, the added expense and time to make extra tillage practice. Generally, furrow systems are more difficult to automate, particularly with regard to regulating an equal discharge in each furrow. And the next type of irrigation is uncontrolled flooding. There are many cases where crop plants are irrigated without regard to efficiency or uniformity. These are generally situations where the value of the crop is very small or the field is used for grazing or recreation purposes. Small land holdings are generally not subject to the array of surface irrigation practices of the large commercial farming systems. Also, in this category are the surface irrigation systems like check basins, which irrigate individual trees in an orchard, for example. While these systems represent significant percentages in some areas, they will not be discussed in detail in this in this presentation. The evaluation methods can be applied if desired, but the design techniques are not generally applicable nor need they be since the irrigation practices tend to be minimally managed. And the next topic is method process involved in surface flow irrigation. In surface irrigation, water is supplied directly to the soil surface from a channel located at the upper reach of the field. Gravity provides a major driving force to spread water over the irrigated field. Once distributed over the surface of the field and after it has entered the soil, water is often redistributed by forces other than gravity. Generally, in a surface irrigation event, four distinct hydraulic phases can be considered. First one is advance phase, next ponding phase, and depletion phase, and the fourth one is recession phase. Uh, First one is advance phase. The time interval between the start of irrigation and arrival of the advancing front at the lower end of the field is known as advance phase. Rate of advance depends on the factors like inflow, field slope, soil intake rate, and surface roughness. And the second one is ponding phase. uh, Ponding phase. The ponding phase is the period of time. One second. The period of time between the end of the advance phase and the cutoff of inflow is known as ponding phase or wetting phase. The term wetting phase is usually used for furrow and border, where tailwater runoff can occur, whereas ponding is the preferred term for basin irrigation. The wetting or ponding phase will not be present if the inflow is terminated before the advance phase is completed, a typical situation in borders and bases, but a rarity in furrows. And the next thing is recession phase. The time required for the water to recede from all points in the channel, starting from the end of the depletion phase, is known as recession phase. Recession continues until either the front reaches the end of the field. Like advanced phase, the rate of recession also depends upon the inflow rate, the slope of the field, the infiltration capacity of the soil, and hydraulic roughness. Recession will tend to be most rapid when the inflow rate is low, the field slope is steep, the infiltration capacity is high, or the hydraulic roughness is small. That's all about the surface irrigation. But recently, surface flow irrigation schemes are down by 9,000 in recent 7 years by a census report. And thank you.